Hello students, welcome to my class. In this video we are going to be discussing about force law for SHM, that related problems, and energy of SHM related problems we are going to be discussing. Let us see the first question. A small body of mass is given as 0.1 kg and here it is executing SHM of amplitude is given as 1 meter and the period is given as 0.2 seconds. The maximum force acting on it is there asking. So maximum force formula will be getting as, this is mass into A maximum, you can take maximum acceleration, which will be equal to m into, here you can take as maximum acceleration formula will be omega square you will be getting. Now here this one even you can write it as time period is given, you have to convert the angular frequency as 2 pi by t whole square into, you can write as A. So mass you have to substitute 0.1 kg into 4 into pi square by t square, it's given as 0.2 seconds is given, 0.2 second whole square into amplitude is given as 1 you have to take, and here you just put the value instead of pi if you are substituting as 3.14, and here the maximum force value will be getting as it's a nearly 98.596 newtons will be getting, right? The maximum force will be getting as 98.596 is the correct answer. Let us see the next question. A body of mass is given as 0.01 kg executing simple harmonic motion about x equal to 0 under the influence of the force. Here the mass is given and here it is right, executing simple harmonic motion about the mean position, and here force versus displacement graph is given. So from the graph here we can say here the maximum force value will be getting given as, here the maximum force is given as 80 newtons is given, and here along displacement axis here maximum displacement will be calling as amplitude. That amplitude is given as here 0.2 meter it's given. You know the formula for maximum force here which you can write it as m omega square into A you can take. Maximum force is given as 80 newtons, here mass is given as 0.01 kg into, here you just convert this one as 4 pi square by t square into, you can write as A. Amplitude already you know that is 0.2 meter. So when you are simplifying this one here t square when you are taking, this is 0.01 into, this is 4 into, here you can write as 3.14 whole square into 0.2 by here this 80 you have to bring into the denominator. If you are simplifying this equation and a square if you are taking that side, so time period of the SHM will be getting as nearly 0.03 seconds you are getting. So this is the correct answer. Let us see the next question. A particle of mass 100 grams, here it is given as 10 grams is given, executing simple harmonic motion with an amplitude is given as 0.5 meter and a periodic time is given as pi by 5 seconds is given. The maximum value of the force acting on the particle they are asking. So maximum force acting on the particle here you can write it as m into omega square into A you can write. So here a maximum mass is given as 10 gram, you have to convert into kilograms, 10 into 1 gram equal to 10 power minus 3 kg into, so omega you can write it as 2 pi by t whole square you can take, it's nothing but 4 pi square into by t square. T square time period is given as here pi by 5, so here I am just squaring pi square by, here you can get it as 5 5 is 25 will be getting, into you can write it as 0.5 is the amplitude. Now here this pi gets cancelled, here you can write it as, this is 10 power minus 2, here 25 4 z will be getting as 100, this 100 and this will get cancelled, here the remaining value will be getting as only 0.5 newtons will be left over. So 0.5 newtons is the maximum force acting on the body. Let us see the next question. Due to the force F1, a body oscillates with the period of 4 by 5 seconds due to the another force F2 with a period of 3 by 5 seconds. So due to force F1 here, a body is going to be oscillating in a 4 by 5 seconds. Due to the another force F2, it's going to be oscillating as 3 by 5 seconds. If both the forces act simultaneously, the new period will be there asking. Then here a force acting for a given period for a given displacement is, this is a formula, F1, let us take F1 we can take, that is m omega 1 square into y you can take. The same way F2 equal to, you can write as m into omega 2 square into y you can take. So they are talking in terms of the time period. In terms of the time period, in the sense here you can take as the resultant force. If both the forces are acting simultaneously, in the sense F equal to F1 plus F2 you can take. F equal to, again here you can take as m omega square into y, which will be equal to m omega 1 square into here into y plus here m omega 2 square into, you can write as y you can write. Now here m into y gets cancelled on both sides. That's nothing but here we'll be getting as omega square equal to, you'll be getting as omega 1 square plus omega 2 square you can get. Omega, the formula will be getting as in terms of time period is 2 pi by t whole square, which will be equal to, it's 2 pi by t1 whole square plus 2 pi by t2 whole square you can get. Now 4 pi square in numerator, when you are cancelling here 1 by t square, which will be equal to, you'll be getting as 1 by t1 square plus 1 by t2 square you can get. When you are simplifying this one here, time period we will be getting as t equal to, this is nothing but here t1 t2 by here we will be getting as t1 square plus t2 square you are getting. t1 t2 already it's given as 4 by 5 into, this is 3 by 5 will be getting, by here we will be getting as 4 by 5 whole square plus 3 by 5 whole square you can take, under root you can take. So in denominator 4 4s are 16 plus 3 3s are 9, 16 plus 9 will be 25, 25 by 25 will be getting as 1 will be getting, and denominator value will be 1 will be getting. So here 4 3s are in numerator, 4 3s are 12, 12 by here will be getting as 5 5s are 25 you are getting, so that value will be getting as nearly 0.48 seconds will be getting. Let us see these questions here. Both of these questions. For a particle showing motion under the force F equal to minus 5 into x minus 2 whole square, the motion they are asking, and here in the given question F equal to minus 5 into x minus 2, the motion they are asking. Here one general formula you can take for the force for both the questions. General form of force is, this is beyond our students, beyond our syllabus students. Here F equal to, here we can write as minus k into, here you can write it as x minus x naught whole power n you can write. So where k will be calling as positive constant, will be calling positive constant, x naught will be calling as equilibrium position, will be calling equilibrium position, and here n value you are take as, so here the conditions will be, if n equal to 1 in the sense, here instead of n, if you are taken as 1 in the sense, n it is given in the equations, then here motion you have to consider as, motion you have to consider simple harmonic motion you have to consider. If n is odd value and greater than 1, if it is given greater than 1, then the motion you have to consider as oscillator. Motion is oscillator. And if n is even number, then the motion is translator you have to take. Translator. So look at these questions here. This is here instead of n it is given as, here 2 is given in this question, F equal to minus 5 into x minus 2 whole square. So 2, it's belong to the even number here. So even number, it represents the translatory motion. The answer will be getting as it's a translatory motion will be getting. Whereas in the second question here, f equal to minus 5 into x minus 2 whole power 1. So nothing will be there here. Right here you have to consider as it's an so simple harmonic motion you have to consider. Here it is 1, it's given. So nothing will be there in the sense, so that motion you have to consider the simple harmonic motion. This fourth general formula if you remember here, students, right? So the answer will be, one is translatory motion and second one is the simple harmonic motion will be getting. Look at the next question. A particle is free to move on x-axis. In which of the following case the particle will execute oscillation about x equal to 1? So particle is moving on x-axis. Let us take here particle is moving on x-axis. So about x equal to 1 it's going to be moving. Now here they are asking which one will execute the oscillation, they are asking, right? So here I am just taking the elimination method, students. For all the cases you have to take the same scenario. Here I am just taking the third one is an answer we will be getting. By taking this answer I am going to be explaining. So here f equal to, here the answer will be minus of, here we will be getting as x minus 1 whole cube will be getting. Now if the particle is displacing, means here if x is greater than 1, here you can take if x is greater than 1, then here force value instead of x, if you are putting the value as greater than 1, in the sense here something 2 minus 1 you are keeping, means 1 whole cube you will be getting, but here 1 cube is 1 and here we will be getting as minus value will be getting. That means here force value will be getting as less than 0 will be getting. Means here if x is less than 0, force value will be getting as, force is going to be acting here, it will be here, this side is x less than 0 in the sense. So force it should be, sorry, this is x greater than 0 in this, greater than 1 in the sense. Here x is greater than 1 in the sense, here f value will be getting as less than 0 will be getting. Less than 0 will be getting. Means here the particle is moving towards the mean position. Whereas in the second case here, if x is less than 1, if you are talking, means here a particle is going to be displacing towards the left extreme position. X is less than 1. Then here x is less than 1 when you are putting in the force formula, right, a force value. So minus 1, here minus 2 whole cube, it will be minus 2 whole cube in the sense, here minus 8 will be getting, minus into minus plus will be getting. So here if the displacement of the particle is less than 1, then force is going to be directed towards the mean position will be getting. Whereas in this case f should be greater than 0. Means here if the particle is displacing right towards right, some restoring force is going to be acting like this. If the particle is going to be displacing towards left, restoring force is going to be bringing back. That means here the given equation f equal to minus of x minus 1 cube, here you have to treat it as a simple harmonic oscillation, right? It's going to be executing the oscillation. It's going to be executing. So third one is the correct answer. Like that each and every like all the other cases also you have to check right, whether it's satisfying or not, right? Please take that one. Next, look at the next questions which are related to the energy of SHM. The first question says a particle is executing SHM with a frequency f. Then the frequency of the kinetic energy, potential energy and total energy they are asking. Kinetic energy general formula will be getting as, kinetic energy the formula will be getting as half mv square. In terms of the time, in the sense here we can get as half into m into v, in the sense here we can get it as velocity formula, you know, here v equal to a omega into cos omega, it will be getting that value you are substituting m into v in the sense here a square omega square cos square omega t you can write. When you are simplifying this one here, half into m into a square into omega square cos square theta you can write it as 1 plus cos 2 theta by 2 you can write. So when you are simplifying this one here, we will be getting as 1 by 4 m into a square omega square into here will be getting as 1 plus cos 2 omega t will be getting. Means here the angular frequency will be getting as omega dash equal to 2 omega, but the displacement of the particle when you are talking a into sine omega t. If the displacement of the particle is varying with the omega or omega equal to will be taken as 2 pi f, but the kinetic energy is going to be varying with the 2 times of the frequency. So here it's going to be varying with the kinetic energy is going to be varying with the frequency of 2f will be getting. Next, the second thing is here potential energy when you are talking. Potential energy formula will be getting as half into k into y square. That means half into k into y in the sense here. This is here will take as again m omega square. Y in the sense here you can take as a square sine square omega t can take. And here a half into m omega square a square into sine square theta even we can write it as 1 minus cos 2 theta by 2 you can take. So when you are simplifying here also will be getting as half 1 by 4 into m omega square a square into will be getting as 1 minus cos 2 omega t will be getting. Means if the particle is oscillating with the frequency f, means here potential energy value it's going to be varying with the frequency 2f will be getting. And the third thing is total energy. Total energy formula generally will be getting as half into m omega square into a square will be getting. Total energy, be remember students, it does not vary with the time. It does not vary with the time. So that here there is no change in the frequency, that is frequency value you are considering as 0. So here if the particle is executing at the frequency of kinetic energy varying with the frequency 2f and potential energy is varying with the frequency 2f, and total energy is independent of the distance and as well as the time, so that here the frequency value will be 0 will be getting. So fourth one is the correct answer. Let us see the next question. The total energy of the simple harmonic oscillator it's given as a particle is E is given, and here if its amplitude and time periods are doubled, then total energy will be there asking. So total energy formula for a simple harmonic oscillator is half m omega square into a square you are getting. If its amplitude and time period are doubled, so here in our formula time period is not there, so you need to bring omega, instead of omega you can take as 2 pi by t whole square into a square you can take. Now just relate the total energy, time period and as well as amplitude. So when you are talking here total energy, I am just indicated the E symbol. E is directly proportional to here you can take as a square by t square you can take. Now here you just take the two values E1 by E2 which will be equal to, here it's nothing but here you can get it as this is T2 square by T1 square into you can write it as A1 square by A2 square you can take. So time period here it is given as double is given. So here you have to take as 2t by t whole square into amplitude and time period both are double is given. So here a by you can take as 2a whole square you can take. A gets cancelled, tt gets cancelled, 2 square will be 4 and here 4 by 4 will be getting, this is 4 by 4 will be getting, 4 gets cancelled, therefore here energy for E1, E2 which will be equal to E1 will be getting. So its total energy will be E alone will be getting. Let us see the next question. The next question says the kinetic energy and potential energy of the particle executing SHM motion will be equal when displacement is. So here when kinetic energy equal to the potential energy here, so what the displacement of the particle they are asking. So kinetic energy for a given displacement, the formula will be half m omega square into, here you can write it as a square minus y square potential energy of the particle for a given displacement is half m omega square into y square you are getting. You just cancel these two values. So a square minus y square equal to, will be getting as y square. Then here you can take as 2y square equal to a square will be getting. Then y square equal to a square by 2 will be getting. Then here particle displacement will be, here it is 1 by root 2 of the amplitude will be getting. Let us see the next question. The next question says the total energy of the body executing SHM is E is given. Then total energy is given as E. Then the kinetic energy when the displacement is half of the amplitude they are asking. So total energy formula will be getting as E equal to half m omega square a square you are getting. Then here kinetic energy formula will be half m omega square into, this is a square minus y square you can take. Kinetic energy when the displacement is half of the amplitude. So here this displacement is half of the amplitude, in the sense what about the kinetic energy they are asking. So now here you can take half into m omega square into a square minus y square, in the sense here you can take as a square by 4 you can take. Now just simplify this one. Here you can write it as 3 by 4. This 3 by 4 a square will be getting, and here will be getting as half into m omega square into a square you are getting. So the new kinetic energy here will be getting as, this is 3 by 4 into E will be getting. This is a kinetic energy when the displacement is here half of the amplitude will be getting. Let us see the next question. Next question says a particle is undergoing SHM when its kinetic energy is equal to the potential energy. Kinetic energy is equal to the potential energy. The velocity of the particle at that position they are asking. So if kinetic energy of the particle which will be equal to the potential energy of the particle, then here velocity at that position they are asking. Kinetic energy for a given displacement is half m omega square into, this is here you can write as a square minus y square. Potential energy for a given displacement here you can write as half m omega square into y square you can write. Then here we have calculated already this equation. Here a square minus y square equal to y square will be getting, and this is nothing but a square which will be equal to 2y square will be getting. Then here with this here y value will be getting as a by root 2 will be getting. So here the velocity of the particle at this position, at this displacement, velocity they are asking. Velocity for a given displacement formula, in a simple harmonic motion, this is a square minus y square, omega into square root of a square minus y square, v equal to omega into, this is a square minus y square, in the sense here you can write as a square by 2 will be getting. So here this is a by root 2 whole square. A by root 2 whole square is nothing but a square by 2 will be getting. Here you can write as 1 minus half will be getting. Here it will be half will be getting. Then v equal to here will be getting as omega into, this is a square by 2. It's nothing but a by, here will be getting as root 2 will be getting. So v equal to omega into a by root 2 is the correct answer. Let us see the next question. If the particle is given as, if the particle repeats its motion after a fixed time interval of 8 seconds. So means here time period is given as, here it is given as 8 seconds is given. Then after how much time its maximum value of potential energy will be attained after attaining its minimum value. So here you just look at the thing, students. So this is the mean position when you are taking. Here at the mean position, here we will be getting as kinetic energy will be maximum. At the extreme position, here we will be getting as potential energy is maximum, and here kinetic energy will be minimum, that is 0 will be getting. And the question they are asking as, here its maximum value of potential energy will be attained after attaining its minimum value. So here from maximum to minimum, here when the particle is going to be moving, in the sense here how much time it's going to be taken. Time taken, which is nothing but here to here, in the sense here will be getting as t by 4 seconds it will take. Maximum to minimum or minimum to maximum. This is the potential energy maximum. Here kinetic energy will be getting as minima, that will be 0. So to get the maxima to the minima, here how much time it will take means for the particle t equal to t by 4 seconds it will take. Already time period is given as 8 by 4, so time it will take as 2 seconds it will take. Now let's see the next question. The next question says the angular velocity and amplitude of the simple pendulum is given as omega. Its angular velocity is given and amplitude is given at a displacement x from the mean position. Its kinetic energy is given as T is given. So here just they have given the symbols. Here kinetic energy is given as T is given, and here a potential energy is given as V is given. Then the ratio of T to V they are asking. Kinetic energy formula you know here for a given displacement is half m omega square into a square minus y square. So this value is given as T is given, and here a potential energy formula for a given displacement is half m omega square into y square will be getting, and this value is given as V is given. You just take the ratios they are asking T by V, which will be equal to here this is here half m omega square gets cancelled. Here we will be getting as a square minus y square. Here some x value is given at a given displacement, x is given. Here you just take here instead of y you can talk about x square you can take, and here also x square you can take. So a square minus x square by will be getting as x square will be getting. This is the ratio of the kinetic energy to the potential energy values. Let us see the next question. A particle is executing linear SHM. The average kinetic energy and average potential energy over a period of oscillation respectively are given as k average and u average. Then here what they are asking, potential energy average in the sense average potential energy is nothing but here you can take as potential energy minimum plus potential energy maxima you can take by 2 you can take. So which is nothing but here you can write as 0 plus maximum potential energy formula will be beginning as half m omega square a square by 2, which is nothing but here will be getting as 1 by 4 here m omega square into a square will be getting. So here kinetic energy average also here will be getting as kinetic energy minimum plus here you can take as kinetic energy maxima by 2 you can take. So it's nothing but minimum kinetic energy here half m omega square a square by 2 will be getting, and kinetic energy also here will be getting as 1 by 4 m omega square a square will be getting. So therefore here what you can take kinetic energy average which will be equal to potential energy average you can talk. So this is the correct answer. Let us see the next question. The next question says the potential energy of the particle, a simple harmonic oscillator, when the particle is halfway to its end point is halfway to its end point they are asking. Potential energy of the simple harmonic oscillator when the particle is halfway to its end point is they are asking. Where E is the total energy. Potential energy you need to calculate. So if you are taking the relation between the potential energy versus total energy when you are talking, which will be equal to, here you can get it as half m omega square into you can take as y square you can take by here will be getting as total energy formula will be getting as half m omega square into a square you are getting. You just cancel these two things, here will be getting as y square by a square you will be getting. That means here potential energy to the total energy which will be equal to here halfway they are asking, means here halfway in the sense here you can take here if the particle is displacing from the mean position y equal to 0 and this is plus a you are taking, this is minus a you are taking, halfway doesn't mean here you can take as at a by 2 distance. So instead of y you can take as a by 2 whole square you can take by a square you can talk. It's nothing but here a square gets cancelled, here will be getting as 1 by 4. So here there is a potential energy of a simple harmonic oscillator u equals to So here and the total energy will be getting as 1 by 4 will be getting. U equal to, here you can get as E by 4. Let us see the next question. The next question says, a body of mass is given as 1 kg is executing simple harmonic motion for a given displacement is given. Its maximum kinetic energy they are asking. Maximum kinetic energy, the formula will be half m into this is here we will be getting as V maxima square. V maxima is nothing but, you know, the formula A omega, that's nothing but A square omega square you can write. So which is nothing but, here mass is given as 1 kg, amplitude, here amplitude in the given equation is here, this is 6 is given, so here but is in centimeter it's given. So displacement it's given in centimeters, so 6 centimeter you have to take, and I'm just converting into the meters, whole square you can take. Omega, instead of omega here it's given as right, y equal to, just compare this one, y equal to a sine omega t plus 5. So instead of omega here what will be here in the sense, here 100 will be there, that value you have to substitute, 100 whole square you can take, it's nothing but 1 by 2 into 6 6 is 36 into 10 power minus 4 into, you can take as 10 power 4. It will get cancelled. Here nearly will be getting as kinetic energy maximum value will be getting as 18 joules will be getting. 18 joules is the correct answer. Let us see the next question. A point particle of mass is given as 0.1 kg is executing SHM with an amplitude of 0.1 meter. And here when the particle passes through the main position, its kinetic energy is given as 8 into 10 power minus 3 joules. Particle when it is passing through the main position doesn't mean here we will be having the maximum velocity and maximum kinetic energy will be having. So here its kinetic energy is given as 8 into 10 power minus 3 joules. Here its amplitude is, here it's given as amplitude is given as 0.1 meter it's given, and here particle mass is given as 0.1 kg. So at the main position it will be having maximum kinetic energy maximum, which will be equal to half m omega square a square you can take. It's nothing but maximum kinetic energy at the main position is given as 8 into 10 power minus 3 joules. Half into its mass is given as here 0.1 kg. This is 0.1 into omega value, we don't know, here omega square into a square. Amplitude is given as 0.1 whole square you can take. So when you are simplifying this one, 8 into 10 power minus 3, which will be equal to 1 by 2 into, this is 0.1 whole square means 0.01, 0.01 into 0.1 will be nearly you can get as 10 power minus 3 into omega square you can take. Minus 3 gets cancelled, 10 powers, 2 8s are 16, then omega square equal to 16 will be getting, and omega value will be getting as 4 radian per second will be getting. Now you calculated the omega value, then here obtain the equation of the motion of this particle. If the initial phase of the oscillation is 45 degrees, then displacement of the particle, here they are given as x. X equal to, you can write it as a sine omega t plus pi. So amplitude, you know, here 0.1 into sine into omega value calculated as already 4t plus, here you can write as pi value, initial phase is given as pi by 4. This is the answer. So 0.1 into sine, here 4t plus pi by 4. Now let us see the next question. The next question says, a particle is executing SHM with the total mechanical energy is given as 90 joules and its amplitude is given as 6 centimeter. If its energy is decreased to 40 joules, then its amplitude they are asking. Energy, total energy formula, which will be writing as half m omega square a square you can take. So here in terms of the amplitude, energy is directly proportional to a square will be getting, and here you can take E1 by E2, which you can take as, this is A1 square by A2 square. Initially here the total energy is given as 90 joules, and thereafter it is decreased to 40 joules is given, which will be equal to here initial amplitude is given as 6 centimeter, 6 whole square by here you can write as a square, you can take 110 gets cancelled, 3 here you can write as this is 9 by 4. It's nothing but here you can get it as this is 9 by 4, which will be equal to 6 6 are 36 by a2 square you can take, and here 9 4s are will be getting, then a2 square which will be equal to 4 4s are will be getting as 16 will be getting, then a value will be getting as 4 centimeter will be getting. So here the final amplitude a2 which will be equal to 4 centimeter you are getting. Now the next question says a particle execute SHM on a line 8 centimeter long. So here it's a line is given, and here it's given as total length of the line is given as 8 centimeters. So from the mean position it's a line length will be here you can write as 4 centimeter will be getting. Its kinetic energy and potential energy will be equal when it's a distance from the mean position is. Kinetic energy and potential energy they are equal, it's given. Suppose here if kinetic energy will be equivalent to the potential energy for a given position, then here for a given position here what the formula, half m omega square into a square minus y square. Potential energy for a given displacement is half m omega square into y square, you can take m omega square gets cancelled, this is a square minus y square equal to y square. Then here with this here will be getting as y equal to a by root 2 will be getting. So here it's a length of the line is 8 centimeter, here it's an amplitude you will be getting as here from mean to the extreme it's a 4 centimeter you will be getting. Then here y equal to here you can write as 4 by root 2, you can write this one as 2 into this one more 2 you can write it as root 2 into root 2 you can take by root 2 you can take, here y value will be getting as 2 root 2 centimeter you are getting. So this is the correct answer. Let us see the next question. The next question says here when the potential energy of the particle executing SHM is 1/4 of its maximum value during the oscillation. So here potential energy of a particle executing is, which is given as 1/4 of the maximum value is given, 1/4 of the u maximum value is given. So the displacement of the particle from the equilibrium position in terms of the amplitude they are asking. So when you are talking about the u potential energy of the particle for a given displacement, the potential energy is maximum when you are talking, which will be equal to here half m omega square for a given displacement you are taken as y square, and maximum potential energy the formula will be getting as half m omega square a square you are getting. But u is given as 1/4 of u maximum, then when you are substituting this u value here you will be getting as 1/4 will be getting, which will be equal to half m omega square gets cancelled, this is nothing but will be getting as y square by a square you are getting. Then here we can take as y equal to y square equal to 4a square will be getting, then y equal to here will be getting as here this is y square equal to will be getting as a square by 4 you are getting, and here y equal to here you can write as a by 2 you can get. So a by 2 is the correct answer. At this displacement, at this amplitude here y equal to a by 2, potential energy will be the 1/4 of its maximum value will be getting. Let us see the next question. The force on a body executing SHM is given as 4 Newton is given, and the displacement from the mean position is 2 centimeter. If the amplitude of the oscillation is 10 centimeter, then the maximum kinetic energy associated with the SHM will be. So here force on a body executing is given as 4 newtons is given. So here the force formula, restoring force formula will be getting as only magnitude when I am talking. Here you can write as k into y for a given displacement. This force value is given as 4 newtons. Here a k they are not talking. Here our displacement is given as 2 centimeter. 2 into 10 power minus 2 meter you can take. Then 2 times will be getting 2 by here 10 power minus 2. Then spring constant, force constant value will be getting as it's a 200 Newton per meter will be getting. Then the maximum kinetic energy they are asking here. Maximum kinetic energy, the formula will be half m omega square a square will be getting. M omega square here even you can write it as k you can take, half into k a square you can talk, which is nothing but k already we have calculated as 200 Newton per meter. It's an amplitude is given as 10 centimeter. So here 10 into 10 power minus 2 whole square you can write. So this is 200 times it goes into here 10 into 10 power minus 2 is 10 power minus 1, and here 10 power minus 2 will be getting. So here it will get cancelled. Then kinetic energy maximum value will be getting as 1 joule will be getting. This is the correct answer. Let us see the next question. The potential energy of the particle of mass is given as 100 grams moving along x-axis. Here u is given as potential energy of the particle is given as 5x into x minus 4 is given, where x is in meters. Here the period of the oscillation they are asking. So just simplify this one, students. 5x square minus 5 4s will be getting as 20x will be getting. So potential energy here they are asking time period of the oscillation, right? So you know, for conservative forces, here F equals, here you can write it as minus du by dx you can write. So here force is here will be getting as negative of negative of change in potential energy for the unit distance you are taking. So here when you are doing differentiation, this value F equal to minus d by dx of here you will be getting as 5x square minus 20x. You can do the differentiation. Here we will be getting as this is 5 2s are 10x. So this will be here minus 10x, minus into minus plus. Here we will be getting as 20 will be getting. This is an F value. Then here which is nothing but here you can simplify this one. F equal to here even you can write it as minus 10 when you are taking common. Here you can write as x minus 2. So it's nothing but F equal to here you can write it as minus kx. So here time period of oscillation, the formula will be getting as t equal to 2 pi into root over m by k you are getting. So it's nothing but 2 pi into mass, it's given as 100 gram. It's under root you can take 100 into 1 gram equals 10 power minus 3 kg by k value we got it as this is 10. So just simplify this one. 10 times here 10 power minus 2. So here 2 pi into root 10 power minus 2 will be getting, it becomes 2 pi into 10 power minus 1 will be getting, square and root we have to cancel. So here we will be getting as this is 0.2 pi will be getting. So time period value will be getting as 0.2, 2 into 10 power minus 1, 0.2 into pi you can take. Let us see the next question. The next question says an object of mass is given as 0.2 kg. Execute simple harmonic motion along x-axis of frequency is given as 25 by pi is given. Frequency is given as 25 by pi is given, and at the position x equal to 0.04 meter. The object has kinetic energy is given and potential energy is given as 0.4 joules. The amplitude of the oscillation they are asking. So here total energy first you need to calculate, which is nothing but potential energy plus kinetic energy you can calculate, which is nothing but here will be getting as 0.5 plus kinetic energy is given as it's a 0.5 plus potential energy value is given as 0.4, which is nothing but 0.9 joules you are getting. Then total energy formula will be getting as half m omega square a square you can write. Then here total energy value, here we need to calculate half into m into the amplitude of the oscillation they are asking. Here omega you can take as 2 pi f you can take. This is 2 pi f whole square you can take into a square you can take. Now total energy already got it as 0.9 joules we are getting. You just cross multiply this one. So it's a 0.9 into this 2 you have to bring this way by 2 into 2 by here you can get it as, this is mass value, it's given as 0.2 kg. So 0.2 also you have to bring this side. So this is 2 pi. Here you can get it as 2 pi into f value is given as 25 by pi you are getting. Whole square into a square you can talk. So this decimals you have to cancel here. 0.9 by 0.2, it's nothing but 9 by 2. So this 2 gets cancelled. Here we will be getting as 9 you will be getting, which will be equal to, here this pi gets cancelled. 2 into 25 will be getting as 50 you will be getting. 50, and here this is 50 whole square into a square you can talk. Then if I am taking the square root that side here, this is 58 becomes, and here it becomes the root 9 it becomes. That means here a equal to, here will be getting as, this is 3 by 50 you are getting. So it's nothing but 0.06 meters will be getting. Amplitude will be 0.06 meters is the correct answer. Let us see the next question. For any SHM, amplitude is given as 6 centimeters. The instantaneous potential energy is half the total energy. Then the distance of the particle from the mean position they are asking. At amplitude 6 centimeter, instantaneous potential energy is half of the total energy is given. That means here instantaneous potential energy doesn't mean potential energy for a given displacement. Half m omega square y square, which will be equal to half into total energy value will be getting as half m omega square a square will be getting. So you have to cancel this one, half m omega square, and this half m omega square gets cancelled. Then y square equal to will be getting as a square by 2 you are getting. Then y equal to will be getting as a by root 2 will be getting. Amplitude already it's given as 6 centimeters. 6 by root 2 you can take, which is nothing but nearly will be getting as 4.2 centimeter you are getting. Let us see the next question. For a particle executing simple harmonic motion, the kinetic energy of the particle is given as k equal to k naught cos square omega t is given, and the maximum value of potential energy and total energy they are asking. Maximum value is nothing but, here you will be getting as, total energy is nothing but, here you can get it as potential energy minimum plus kinetic energy is maximum. So here it's a kinetic energy itself is given as k naught cos square omega t is given. If kinetic energy is maximum in the sense, here we will be getting as potential energy will be minimum we will be getting. Potential energy is minimum. If the kinetic energy is maximum in the sense, potential energy will be minimum we will be getting, that will be 0. That means here even total energy, even you can write it as, here also you can write, so potential energy maximum plus here you can write as kinetic energy minimum you can write. So in this case here what will be getting, potential energy maxima is nothing but, here will be getting as total energy. It's a total energy alone. And kinetic energy maxima, this is a potential energy maxima, which is nothing but total energy. Kinetic energy maxima also, it's nothing but, here will be getting as total energy will be getting. In both the cases here it's given as the kinetic energy maxima, which will be equivalent to here potential energy maxima, which will be equal to kinetic energy maxima will be getting. Kinetic energy maxima will be equivalent to total energy will be getting, which is nothing but, here you can get it as k naught you can get. So in both the cases here we will be getting as k naught, and k naught is the correct answer we will be getting. Let us see the next question. The potential energy of a particle with the displacement x is given as u of x. The motion is simple harmonic where when k is a positive constant. Potential energy of a particle for a given displacement x means here if the particle is displacing from the mean position, so here you can write as here if the particle is displacing and here restoring force is going to be acting like this, and here work done against the restoring force, which will be here will be getting as dw equals here will be getting as f into dy. It's a minus value. This is here will be getting as dw equals to here you can get it as f in the sense here will be taken as minus ky into you can get it as dy, you can take restoring force formula. It's nothing but dw equals here will be getting as ky into dy will be getting, right? So here integral total work done is nothing but here you can take as integral dw, which will be equal to 0 to y you can take. It's nothing but here you can get it as k into y into dy you can take. Here we will be getting as dw equal to force into displacement. It's both will be in opposite direction, so that we will be getting as a minus value, and here fr equal to minus ky will be getting, and here you can get it as minus ky into dy will be getting, and 0 to y ky into dy will be getting. So work done can be stored in the form of the potential energy of a particle, which is nothing but here will be getting as half into k into, this is when you are doing differentiating and integration, k into y square by 2 will be getting. So work done equal to u will be getting here, which is nothing but half into k into y square you will be getting. So here it's a u equal to minus half, sorry here all I took it as x values, here it is dx you can take, here it is x, and here it is x you can take, and here also x you can take, and here it is x square by 2 you can take, and here it is x square by 2 you can take. So here first one is the correct answer. Let us see the next question. The next question says the kinetic energy of the particle executing SHM is 16 joules when it is at a mean position. So here if the mass of the particle is 0.32 kg, when what is the maximum velocity of the particle they are asking. So kinetic energy here maximum, which will be equal to here will be getting as half into m into v maxima square you can take. It's nothing but v maxima square, which will be equal to 2 into kinetic energy by here you can take as m you can take. Square you have to take that side, here it becomes square root. Therefore v maxima, which will be equal to 2 into kinetic energy maxima is given as 16 joules is given. Means here at the mean position, in the sense you must right talk about the maximum kinetic energy, students. 16 joules by here mass it is given as 0.32 is given, 0.32 kg, it's under root. Now here when you are simplifying this one, here will be getting as 2 16 32, 32 by here will be getting as 0.32, here it's under root, here it is 100 times it's going, and here it is root over 100 is nothing but will be getting as 10 meter per second will be getting. So 10 meter per second is the correct answer. Let us see the next question. A body is executing simple harmonic motion at a displacement x. Its potential energy is given as E1, and its given displacement y, its potential energy is given as E2 is given. Potential energy for a given displacement you can write it as half into k into y1 square you can take. For a given displacement y it's given. Means here you can get it as this is at a given displacement x, its potential energy is here let us take as here it is x you can talk, x square. That means here with this here x equal to here you can write it as this potential energy is given as E1 is given. So x equal to here you can write as 2E1 by you can write as k you can take under root. Whereas in the second case E2 is given as for a given displacement half into k into here it is given as y is given, y square you can take. With this here y equal to here you can write as 2E2 by k you can take. Now the potential energy E for a given displacement x plus y they are asking. E is nothing but here you can get it as half into K into here x plus y displacement means here you can take like this potential energy. That means from this here x plus y which will be equal to, you can write it as 2E by K, you can write it's an under root. X is nothing but already you know, here it's nothing but 2E1 by K will be getting, plus here it is 2E2 by K will be getting under root, which will be equivalent to here you can write as 2E by K, you can take 2 by K on both sides you have to cancel, square root also you have to cancel. The remaining values will be getting as root over E1 plus root over E2, which will be equal to, will be getting as root E will be getting. So this is the correct answer. Let us see the next question. The next question says the maximum kinetic energy of the oscillating spring is 5 joules is given and its amplitude is given as 10 centimeter. The force constant of the spring they are asking. So kinetic energy maximum, the formula will be getting as half into K into A square you are getting. Maximum kinetic energy is given as 5 joules, which will be equal to half into K into A value 10 centimeter is given. Here you can write as 10 into 10 power minus 2 whole square you can take, and here we will be getting as 2 5s are 10 will be getting, which will be equal to K into, this is 10 power minus 1, it's nothing but here you can take as 10 power minus 2 you can take. That doesn't mean here K value will be getting as 10 power 3 will be getting. Newton per meter is the correct answer. Let us see the next question. The next question says here the amplitude of the particle executing SHM is made 3/4 keeping its time period of the constant. The total energy will be there asking. Means here the amplitude of the particle executing SHM is made 3/4 by keeping its time period constant. So here you just look at the students here, a time maximum kind of energy formula will be, total energy formula will be half m omega square A square. In terms of time period when you are talking here, half into m into, here you can take as 2 pi by t whole square you can take into A square you can take. E is directly proportional to, here we will be getting as A square you are getting. That means here E dash by E, which will be equal to, here we will be getting as, this is here like you can take as A dash by A whole square you can talk. It's A dash is nothing but 3/4 SHM is made 3/4 it's given. So 3/4 of the A by A whole square you can talk. A gets cancelled here. E dash is nothing but here will be getting as, it's 3 3s are 9, 9 by 16 times of the total energy will be getting. Let us see the next question. The next question says here a linear harmonic oscillator of force constant is given. So force constant value here it is given as 6 into 10 power 5 Newton per meter is given, and amplitude is given as 4 centimeter it's given. And here the total energy value is given as here 600 joules is given. Select the correct statement they are asking. So total energy is nothing but here you can write as potential energy maximum plus kinetic energy minima you can take. So kinetic energy is minima is nothing but 0 will be getting. So total energy is nothing but here will be getting as potential energy is maxima, which is nothing but 600 joules will be getting. So maximum potential energy here, first option is going to be satisfied. Now let us talk about the kinetic energy maximum. Kinetic energy maximum, the formula will be getting as half m omega square A square, half into mass it is given as, or instead of m omega square here mass they are not talking, half k A square you can take. K value is given as 6 into 10 power 5 and amplitude is given as 4 4 that's 16 into here 10 power minus 2, 10 power minus 4 you can take. So when you are simplifying all these things here, kinetic energy maxima you will be getting as, it's a 480 joules you are getting. So 480 joules is the maximum kinetic energy also, it's going to be satisfied. Now let us take this scenario. Total energy is nothing but kinetic energy maxima plus here you can take as potential energy minimum you can take. Total energy is given as 600 joules. Kinetic energy maximum will be getting as 480 joules will be getting. Then here you just calculate the potential energy is minimum. Then potential energy minima will be getting as 600 minus 480 will be getting as 120 joules is the correct answer. So third option also it is going to be satisfying. So all of this is the correct answer. Let us see the next question. The variation of potential energy of harmonic oscillator is shown in figure is given. Here the spring constant value they are asking. So this basic formula for potential energy of a simple harmonic oscillator is at the extreme position will be getting as U equal to U naught plus here will be getting as half into K into A square will be getting. That means here already the particle is displacing here this much potential energy. This is the U naught is the minimum potential energy will be calling. So U equals to here it's given as here 0.04 joules is given. This is a 0.04 joules which will be equal to U naught is given as 0.01 joules plus here you can take as half into K into A square you can take. Then 0.04 minus 0.01 which is nothing but here will be getting as 0.03 which will be equal to half into K into amplitude here it's given as here 20 millimeter is given. So 20 millimeter means 10 power minus 3 whole square you can take. So here when you are simplifying this one here K value, this is K value will be getting as nearly 150 Newton per meter will be getting. 150 Newton per meter is the correct answer. Let us see the next question. The potential energy of a particle of 1 kilogram along x-axis is given as U equal to here 5 into 1 minus cos 3x is given. Now here you just simplify this one 5 minus 5 cos 3x will be getting, and here for conservative forces the formula will be F equal to here you can write it as minus du by dx. So just when you are doing a differentiation here this value will be 0 and here minus 5 into cos 3x will be minus sin 3x into will be getting as 3 will be getting. So it's a minus into minus plus. Here will be getting as 5 3s are 15 into sin 3x will be getting. So for small small oscillations means for small oscillation sin 3x value you can take as 3x you can take. So F value will be getting as 15 into 3x which is nothing but 45x will be getting. So here F equal to when you are comparing with this F equal to kx, this is kx, instead of k will be getting as here 45 will be getting. So k when you are talking here then t equals to time period formula will be getting as 2 pi into root over m by k you can take. This 2 pi into mass will be getting as 1 kg by k value you can take as 45, which is nothing but here will be getting as here this one you are writing as 2 pi by 3 root 5 you can take. 3 3s are 9, 9 5s are 45. This is the time period value 2 pi by 3 root 5 will be getting.